this tutorial, we will discuss what makes an airplane fly, and we'll learn some important terms and concepts along the way. But first, let's learn about the Bernoulli's Principle. Daniel Bernoulli, who is a Swiss mathematician, expanded on Newton's ideas and discovered the motion of fluids. He described in his 1738 publication Hydrodynamica the basic principles of airflow pressure differential. The principle simply states that as the velocity of a fluid such as air increases, its pressure decreases. Let's take a look at the diagram to understand this concept a little better. As the air or fluids in general travel through the tighter passage of the tube, the velocity increases since fluids travel at a faster speed to reach the end of the curve. What's interesting, when he measured the pressure, Bernoulli discovered that every time the velocity increased or decreased, the pressure would have the opposite effect. In this slide, we will define a very important force that will help us understand the future concepts. That force is the relative wind. The relative wind is simply the airflow that is parallel and opposite to the flight path of the airplane. An airfoil is any surface, such as a wing, that provides aerodynamic force when it interacts with a moving stream of air. When given a flight path and an opposite relative wind, it's important to remember that the airflow over the surface of the wing will have a higher velocity than the airflow under the wing. It's also important to note that the circulation of the airstream about the airflow is an important factor in the generation of lift. The camber. It is the characteristic curve of the airfoil's upper and lower surfaces. The chord line is an imaginary straight line drawn through the airfoil and the direction of the relative wind. The chord line is a very important determinant of what's called the angle of attack. The angle of attack is simply the angle between the chord line and the airfoil at the direction of the relative wind. In this slide, we will learn that as the angle of attack increases, the lift also increases. Please note that the lift acts perpendicular to the relative wind, regardless of the angle of attack. According to Bernoulli's theorem, the increased speed of the air on top of an airfoil produces a pressure drop. This lowered pressure is one component of a total lift. However, when the angle of attack is increased beyond the maximum allowed, the lift is decreased. This causes what's called a stall. As we mentioned earlier, a stall is a result of a critical angle of attack. It is also caused by the disruption of the airflow from the upper surface of the wing or airfoil. The airflow then separates at what's called the trailing edge. The airflow progresses forward until the wing is fully stalled. Therefore, a stall is a rapid decrease of lift caused by separation of airflow. In this slide, we will learn about the four very important forces of flight. The challenge to understand what makes an airplane fly starts with learning the four forces of flight. During a flight, the four forces acting on the airplane are lift, weight, thrust, and drag. Lift, as we discussed earlier, is created by the effect of airflow over and under the wing. The weight of the airplane, that is the force caused by gravity. The thrust, that is the force that propels the airplane. And finally, the drag, which is the force that limits the speed of the aircraft. By now we have established that the lift is the key aerodynamic force. Please remember that when weight and lift are equal, an airplane is said to be in a state of equilibrium, and that means lift equals weight. Also, when vertical and horizontal forces are applied, as shown on the left of the slide, the resultant force acts in a diagonal direction. Therefore, the resultant of two opposing forces which are equal in magnitude is 0. I hope you enjoyed the tutorial and thank you for watching.